Assalamualaikum guys, welcome to my YouTube channel. It's me Hania. So once again with you with my maths, and today again fraction is our topic. As you know, we are in love with fraction these are days, because I don't want to change a lecture topic because it is going to irritate you if I'm going to change a lecture or topic. So that's why let's discuss math with multiplication of fractions. We have done different type of things. We have done addition and subtraction of fractions, we have done introduction, we have done equivalent fractions, like and unlike fractions. So let's learn about multiplication of fractions in this class. So first of all, you should know what are equivalent fractions or that. So equivalent fraction are those fractions that represent the same amount even though they may appear different. So even though if the writing amount, if the writing way is different, it does not matter. The amount that hold, if that is same, that means they are equivalent fraction, they are equal in value, but they are representing different, holding different fractions. So do you think these following of these figures, they are the equivalent fractions, like 1 over 2 equals to 3 over 6 equals to 4 over 8? So let's check. First of all, we are going to do multiplication. So 2 multiplied by 2 2 multiplied by 3 equals to 6, and 1 multiplied by 3 equals to 3. 2 multiplied by 4 equals to 8, and 1 multiplied by 4 equals to 4. That means these are fractions are equivalent fraction because they hold the same value even though they are representing differently. So let's take example again, like fraction with that are equivalent fractions. So the that are equal in value, whatever fraction you to look, that's going to be equal in value, you're going to say this is a equivalent fraction. Like first of all I'm having 1 over 2. Okay, so in this 1 over 2, you can see I'm having a whole that's divided into two equal parts, and one of that is shaded. Then I'm having 2 over 4. Here there's 4 whole that's having 4 total parts, and two of them are shaded. 3 over 6, here's a whole that's having 6 total parts, a whole in a whole, 6 total parts, and 3 of them are shaded. 4 over 8 total, a whole is a whole, it's having 8 total parts and 4 of them are shaded. So if you look at these amounts that shaded portion are, so this is a half, but it is represented differently. But you can also look over here that the circle is also equal. So without working, I can just acknowledge that this is a equivalent fraction. So for these type of things, we do not need to do a long working if they are not asking. If they're asking, do we have to do the working? But if they're not asking, so there is no important need. But let me do the working. So first of all, we have to check for 2 over 4. So 2 multiplied by 2 equals to 4, and 1 multiplied by 2 equals to 2. It creates 2 over 4. 3 over 6. So 1 multiplied by 3 equals to 3, and 2 multiplied by 3 equals to 6. 3 over 6 is also equivalent. 4 over 8, so 1 by 4 equals to 4, and 2 multiplied by 4 equals to 8, and this is also the same fraction. That means they are equivalent fractions. So both way you can do, but if they are saying you to do working, so it's important to do this one working. Okay, then you have to check your knowledge. You have to just look, you have to give your answer on your own, but let me tell to you because it's my work. So equivalent fractions, like first of all, you should know again what are equivalent fractions. Equivalent fractions are fractions that represent the same amount or size of the shaded portion of a whole. So here I can easily get to know that yesterday in last part what I have said you, that what we have to do is if there is a circle, if that's containing the same amount, so if the circle is having or shaded portions, if they are same, so we can simply get to know yes as the answer. So but let's do the working. Okay, look over here. No working is needed for this because here we are having a circle that is showing the same pictorial representation that these all are equal, and the circle is also equal. So simply I'm going to tell the yes as the answer, because here it's simply telling us yes, they are equivalent. So do these figure represent equivalent fractions? Like this figure, it is 2 over 6, and this figure is 4 over 7. It's having 7 total parts, 4 of them are shading, and this people in this we're having 6 total parts and 2 of them are shaded. So first of all, you have to check for their simplification if they're simplified. So we have to check for that. So 2 over 6 they are divided by 2, so that means they are 1 over 3, and 4 over 7 is not divided by anything. So that means 1 over 3 and 4 over 7, if you multiply them or divide them, so there is no, there is no possibility. So as equivalent fraction represents same amount and size of a shaded portion, so they do not represent, so that means they are not equivalent. So let me tell you an important fact about multiplication that I tell you in the last video, that was order of numbers or fractions in multiplication does not matters. And last video I tell you about subtraction. It order of numbers or fractions in subtraction matters. But if you're discussing about multiplication, so what I'm going to say is in order of fractions and numbers in multiplication does not matters. Like take example, if I'm having six groups of 9, like that means 6 multiplied by 9. So if I'm having 9 groups of 6, that means 9 multiplied by 6. So they are same. Answer is going to be same, like 10 times 8, 10 multiplied by 8, and 8 times 10, 8 multiplied by 10. So the answer is same, like 9 twelfths of 5th. So that means 9 over 12 multiplied by 5th, like, even though I say 5 times 9 twelfths, that means 5 multiplied by 9 over 12. So both way we are having the same answer. So whatever way you want to do, so it's your choice. Like here I'm having an example that I have to multiply 2 multiplied by 3 over 5. So as multiplication is repeating the addition, so let's check its pictorial solution above the question and with both addition and subtraction sentences. So what's 2 times addition of 3 over 5? So first of all you have to do it pictorially. So take a figure that's having 5 equal parts and 3 of them are shaded. Then take another figure that's having 5 equal parts and 3 of them are shaded. That means 3 over 5 plus 3 over 5. So that's repeated addition now, because here we have to do 2 times. You have to combine all the colored parts. So that means we are having this fraction 3 4 5 6. 6 over 5 is our answer. And let's do this one. If we are doing with multiplication, we can do two groups of 3/5. Like here we are going to have fifth, that is a figure that having 5 total and 3 are shaded. Then a figure that's having 5 total parts and 3 of them are shaded. Okay, then like, we are doing 2 multiplied by 3 over 5. That means 2 over 2 times 3 over 5. Okay, so you have to combine all the color parts to get a product. Okay, so just combine them, and the same as this, like it's having the same product, 6 over 5. So now let's multiply the fractions with whole numbers. Like first of all you have to multiply 16 wholes and 3 over 8 and reduce to its lowest form. Like first of all we have to check for the whole numbers. If they are whole numbers, you have to convert them to fractions. So here was 16, so we have to put 1 under it. That makes 16 over 1 multiplied by 3 over 8. Then you have to check for simplification. Here I get to know 16 and 8 are divided by 8. It's your choice if you want to divide it by 8, 4, 2. It's your choice, but I want to divide by 8 because it's short. So 16 and 8, that I get 2 over 1 multiplied by 3 over 1. Now no more simplification possibility. So now I'm going to multiply the numerator with the numerator and multiplication denominator with the denominator. Like what you have to do is multiply the numerators and multiply the denominators. Like 2 over 3 over 2 multiplied by 3 and then 1 multiplied by 1. Okay, so you get 6 over 1, and you have to simplify the fraction if possible. Okay, so if it's possible, so simplify. There is no possibility, so I'm not going to simplify. That simply gives me 6 over 1. That means 6 wholes. So you have to multiply fraction with fraction. How we can multiply fraction with fraction? So solve 5 over 7 of 14 over 3 and its reduced lowest form. So if whenever we're going to have an off sign, you're going to change into multiplication sign. So off is going to change to multiplication first of all. Then you have to check for all this simplification of numerator and denominator. Like 5 over 7 multiplied by 14 over 3. Here I get to know 7 and 14, they both are divided by 7. So that gives me 5 over 1 multiplied by 2 over 3. Now no more simplifications. You have to multiply the numerator with the numerator, denominator with the denominator. Like 5 multiplied by 2 over 1 multiplied by 3, I'm going to get 10 over 3. Then we have to simplify the fraction if that's possible, and we have to convert it into mixed number or improper fraction. So it's improper fraction, 10 over 3. So we have to convert it into a mixed number, QRD form, like 3 whole 1 over 3 is the answer. So you have to multiply a mixed number by a mixed number. How we can multiply a mixed number by a mixed number? So we have to multiply 10 whole 2 over 3 multiplied by 3 whole 1 over 6. So first of all, you have to convert the mixed number into improper fraction. So what I have to do is 10 multiplied by 3 equals to 30 plus 2 equals to 32. So that means 32 over 2, 3. So and then 3 multiplied by 6 equals to 18, and 18 plus 1 equals to 19. So I'm going to get 19 over 1. So fraction I'm getting is 32 over 3 and 19 over 6. So then you have to check for the simplifications of the numerators and the denominators, like 32. Here I got to know 32 and 6 are divided by 2. So just divide them and we're going to have 16 over 3 multiplied by 19 over 3. So we have to multiply. The next step is that we have to multiply the numerator with the numerator, denominator with the denominator, like 16 multiplied by 19 over 3 multiplied by 3, so that give me the answer 304 over 9. So like, of course, it's an improper fraction to convert into mixed number, and there's no more possibility of simplification. So convert it to mixed number QRD form, and that equals to 33 whole 7 over 9 is the answer. So multiplying three fractions. So let me tell you one important point about this: one simplification at one step. So at one time we can do only one simplification of two numbers. So that means there that is one denominator and one numerator we can just simplify at one time. Okay, so then example 4 is you have to solve to whole 2 over 3 multiply by 10 over 4, you have to, and multiply by 5. So first of all, you have to convert the mixed number into a proper fraction and write whole number as the fraction. So 2 multiplied by 3 equals to 6. 6 plus 2 wait, yes, 6 plus 2 equals to 8, and I'm going to have 8 over 3. Then 10 over 4 is going to remain same, and 5 over 1, like you have to just convert it. So under 5 you have to put 1. So now fractions I'm getting is 8 over 3, 10 over 4, and multiply by 5 over 1. So then you have to check for all the possible simplification of numerators and denominators. So 8 over 3 and 10 over 4. So in these 8 and 4, they both are divided by 4. So divide them and to get 2 over 3 multiplied by 10 over 1 multiplied by 5 over 1. Then you have to multiply out the numerators and denominators, because there is no more simplification, and in the end if there is a simplification, so you have to simplify it and convert into improper fraction to mixed numbers. So equals to, you have to multiply the numerator with numerator and denominator with the denominator. 10 multiplied by 10 equals to 5 multiplied by 5, and then 3 multiplied by 1 equals to multiply by 1. So I'm going to have 20 over 3. So then it is simplified by 3. So we have to simplify that. I'm going to multiply first fraction with 5 and then second with 1. I'm to have 1000 over 3. Then I have to, like, it's improper fraction, so let's convert into mixed number. So QRD form equals to 33 wholes 1 over 3. Then you have to solve 1 whole 4 over 5, and multiply by 7 over 12 of 18 over 30. So first of all, what you have to do is you have to convert the improper fraction mixed number into improper fraction, and you have to change off into multiplication signs. 1 over 1 multiplied by 5 equals to 5, and plus 4 equals to 9. So I'm going to have 9 over 5. Then 7 multiplied by 12 is going to remain same. 18 multiplied by 30 is going to remain same, and off this here, this off would be changed into multiplication sign. So you have to check for all the possible simplification of numerators and denominators. I'm having 9 over 5 multiplied by 7 over 12 multiplied by 18 over 30. So here 12 and 18, they both are multiples of 6. So let's multiply them. I'm going to have 9 over 5 multiplied by 7 over 2 multiplied by 3 over 30. Then I'm getting that 3 and 30, they both are divided by 3. So let's divide them. Now I'm having 9 over 5 multiplied by 7 over 2 multiplied by 1 over 10. Now no more simplification is possible. So we have to multiply the numerators with numerators, denominators with denominators, and then simplify the fractions if that is possible. So 9 multiplied by 7 multiplied by 1 over 2 multiplied by 2 multiplied by 10 equals to 63 over 10, and then there's simplification, so we have to multiply that 63 with 1 and 10 with 10. So I'm going to have 63 over 100, and it is proper fraction, so no conversion to mixed number. So this is your homework for me. So like, you just think that this is homework given to you by me, that you have to find a product of 5 over 3 over 7, 6 and 8 over 28, and you have to solve 5 over 6 of 30. So I hope you like today's lecture, today's video. And thank you for listening to me. Thank you so much. Have a great day. See you in the next lecture. Allah Hafiz.